Okay, in this introduction to recurrence relations, we're going to look at how we can describe sequences. So most of us are used to sequences. They can either go up by a certain amount, they can multiply by a certain amount, or sometimes they do more than one thing. So let's have a look at filling in the gaps for these sequences. This one here we can see visually, you can see it's going up by a certain amount every time. So it's going up by 20. And so the next number in the sequence you'd expect to be 180. The next one, let's see if you can work out what's happening there. The operation is the same every time, timesing by 2, so you'd expect the next one to be 16. And the last one here is 2 operations every time. So just pause the video and see if you can work it out. Okay, the first operation is you are timesing by 3, and then you are subtracting 1. Times 3, subtract 1 every time. Okay, so the next number you'd expect to be 3 times 14, which is 42. Take 1 gives us 41. Okay, now some of these sequences are easy to describe, but some of them, obviously the last one there is a little bit harder to describe, and so we have categorized different types of sequences, and we're going to talk about how we can describe them in the next bit. So first of all, you've got these arithmetic sequences. Now arithmetic sequence means that it goes up by a set amount every time. So in this case, we're going to describe it using this difference equation. Okay, difference equation is like a rule. Sometimes we call it a recurrence relation. There's 2 different names for the same thing. And the way that this works is a little bit like an algebraic rule, but not quite the same. It shows you how to find the next term in the sequence. So the way the language works is this here, tn plus 1 means next term. So that's the next term in the sequence. Tn is any term. So the term that you're currently looking at. T1 is the first term. So the first term for this sequence is obviously 5. And lastly, this is the bit that makes it arithmetic, this is called the common difference. Okay, and that's for arithmetic only. So the common difference here is going up by 4 every time. So what this actually tells us in words is first number is 5. Okay, that's what that tells us. And the next thing, the next part of the rule says add 5 to get the next term. Okay, and that's what this part tells us. So now we can fill in the box down here. So here, the table has different values of n. So I've got like n being 1, which we know Tn is 5 in that situation. If n is 2, we expect Tn, the second term, to be 9, because you're adding 4 every time. And so the next one you'd expect to be 13. And the next one after that you'd expect to be 17, because it's plussing 4 every time. Now, sometimes you want to jump all the way to the 10th term. So for this, a difference equation takes a long time because you've got to do every single one step at a time. But an equation or a rule allows us to get to any term with one calculation. So in order to find a term, you have to use the rule for an arithmetic sequence. So for an arithmetic sequence, being a sequence which goes up by a common difference every time, the rule is Tn equal to A plus n minus 1 times D. Now let's just break down what that D is the common difference. So in this case it's going to be 4. And A is the first term. So what I'm going to do now is I'm going to sub in the values from the recurrence relation above. So Tn is going to be equal to 5 plus n minus 1 times by 4. And I'm then going to expand the brackets, expanding the brackets by multiplication. And I'm going to get Tn equals 5 plus 4n minus 4. Okay, if I then put those together, collecting the like terms, 5 and negative 4 make positive 1. So I'm going to get 4n plus 1. Now, that's a bit of algebra for you, but in simple terms, what that equation is doing is allowing us to find the 10th term. So let's just see what we're actually doing here. We're starting with the number 5. Okay, this is for the 10th term now, so for T10. We're starting with 5, and we're adding on 9 lots of 4. Now, why are we adding on 9 lots? Why? If you think about it, we're already at the first term, so how many more jumps is it to the 10th term? It's times 9, because you're already on the first term. And so that solves to find the answer there. So 9 times 4, 36, plus 5, 41. Now, that's doing it with common sense method, but we can also use our equation, n plus 1. So therefore T10 equals 4 times 10 plus 1 equals 41. So this equation works every time now. So that's arithmetic sequences. With geometric sequences, we are multiplying every time. So very much the same. This recurrence relation tells us two things. It says first number is 2. The second thing it says is multiply by 3 to find the next term. Okay, so this will generate the sequence 2. So you got n when n is 1, n is 2, n is 3. And then I'm going to skip to 10. And then I want to skip to... Okay, so the first term is 2 times by 3 makes 6 times by 3 makes 8. So to get the 10th term, I'm going to get the starting number, put it into this equation here. So this is for geometric sequences. So you get your first number and you times it by what we call the common ratio to the power of n minus 1. Okay, so once again, this is your first number, and this is what we call the common ratio. So in the case of this question, Tn equals 2 times, because the first number is 2, times 3 to the power of n minus 1. Now, let's use that to find the 10th term. So T10 is equal to 2 times 3 to the power of 9. Okay, so 9, because we need to multiply by 3 9 times to get to the 10th term. Okay, times 9 times. So that will get us our final number, which is actually a calculator job really. So 2 times 3 to the power of 9 gives us 39366. So that's quite a big number for the sequence. Now, that brings me on to the final part of talking about what these sequences look like on a graph. So, a graph of an arithmetic sequence would look linear. Okay, so for every value of n, the value of Tn goes up by a set amount. So they tend to be straight lines, going either up, or they could potentially go down as well. Okay, whereas if we look at geometric, we can get a variety of shapes depending on what the ratio is. So the common ratio being the multiplier every time can make it go in different shapes. So one option is that you have it go very steep curve, which is what we saw in the last example. The other option is you can have it going down in a steep curve, or actually if the numbers are negative, you can find that they go above and below the 0 line, so actually like below like that. So they will vary, but generally they are non-linear, okay, versus linear, and that's because it's not being multiplied, it's just going up by a fixed amount. So that's an introduction to the different kinds of recurrence relations. Hopefully that helps recap on Year 11 work.